JSON changed the world because it unified how we serialize data across all the web. But JSON was designed in 2001. So today we are still encoding universal unique IDs as strings, or we are parsing standard timestamps by hand. For this reason, I have been working on something to fix all of this. It's called xCDN, Extensible Cognitive Data Notation. It's a new data serialization format designed for modern cognitive computing. It keeps the simplicity of JSON, so curly braces, square brackets, and key value pairs, but add all the semantic richness that we need. Add native types, streaming capabilities, all we need in 2026. And as of recently, application/xCDN is an officially registered YANA media type. So, isn't a toy. It's a real standard track format with parser implementation in Rust, in Python, in JavaScript, and in C. Let me walk you through the design, the specification of xCDN, and why I think all these things matters. We can start talking about main problems with JSON. So let's open the terminal and let's copy and paste an example of a typical API response in JSON. Every single value here is a string. So 19 and 99 is a string. Is a string or a decimal? This is a universally unique identifier, but it's validated. Who knows? This is a data, but the date in what is the format is the date in. To understand all of this, you need an external scheme validation, or you need to build parsing logic into every consumer, because the format itself have zero semantic information. And there is also the developer experience, because comments like these are not allowed. So it's difficult to write documentation inside this data format. There are no trailing commas. Is another kind of difficult when you, for example, try to copy and paste data or move around the data to order it. There are also other new systems, for example JSON 5, that try to fix some of these, but it's more or less syntax sugar, because JSON 5 didn't, for example, address the type system problem. There is YAML that have maximum flexibility, but its implicit typing causes real bugs. There is the famous Norway problem. String no gets parsed as a boolean. There is also TOML, that is a clean format but is flat and completely sacrifices the human readability. xCDN sits in this specific gap because is human readable, is machine unambiguous, and have a rich type system with zero implicit coercion. Before I show you the syntax, let me explain the design decisions behind xCDN. So we can delete all of this. And we start with the first principle. xCDN is a format human first, but machine optimized. xCDN files should be readable and writable by a developer in any text editor, and at the same time parser should never have to guess types, because every type is explicit. Second principle, superset thinking. valid JSON is conceptually very close to a valid xCDN. So if you know JSON, the learning curve of xCDN is near zero. Third main point, cognitive computing readiness. This is the cognitive in the name. When you are building something like an agent system, an LLM pipeline, or an event-driven architecture, you need to stream data, you need metadata, and you need also semantic tags. All of these things are built inside xCDN. Fourth, no implicit behavior. Unlike YAML, for example, xCDN never guesses. So a decimal is a decimal. A duration is always a duration because there is a prefix. It's unambiguous in any case. Now let's look at the native types, because xCDN supports everything JSON supports, so string, numbers, boolean, null, object, and arrays, plus 5 additional scalar types with prefixed string literals. So we can start showing these types. We can start with decimals. So, for example, max cost is a decimal, 19 and 99. This is an arbitrary precision decimal, not a float, not a double, but a decimal. This is very useful, for example, for financial applications that can't lose pennies or rounding during information transfers. Universally unique identifier use another prefix. So my ID is equal to U, and I copy and paste something. Okay, this is my UUID. The parser validates the format at the parse time, so you don't need runtime checks to understand if this ID is valid or not. The datetime use another specific format, the prefix T. So I can copy and paste something inside this specific format, 2026, okay. And we have always a specific date in a specific format, parsed and validated at parse time. Duration is another format. In this case, the prefix is R. The duration used ISO 8601 standard. So this is a standard duration. Bytes use B as a prefix with base 64 encoding. So this is an icon with the B prefix. Inside we can copy and paste the start of an image base 64 encoded. This might seem minor. You could argue that prefixed strings are just convention, but the difference is that the parser enforces these specific types. So when you deserialize xCDN, you get actual decimal object or actual universally unique ID object, not a string that you have to post-process. Now it is where we can talk about semantic, tags and annotation. In this point, xCDN starts to diverge from JSON with types. We have two orthogonal extension mechanisms. The first one is tags, and the second one is annotations. Tags are prefixed in this way. So I can, there is this I, okay. I can, for example, create an admin key with the tag user. And inside I can simply copy and paste, as always, my ID okay. In this way, I have a domain-specific meaning for the admin key. So your application can register endless for user, for any tag your specific domain needs. The parser gives you the tag and the value, and the code decide what to do with these two different informations. This is explicit extensibility, so you are not overloading strings with implicit semantics. You can use tag for domain-specific explanations. We have also annotation. Annotation are prefixed with an at and carry metadata. So this user can have an icon with a MIME specific type. This is, for example, an image PNG. We have a we can copy directly this binary encoded data. Perfect. And as you can see, annotations are non-intrusive because they provide hints, and as you can see, annotations are non-intrusive. They provide hints without modifying any of the data model. Think of them like a kind of decorators in Python or an attributes in C#. In this case, the data is the byte string. The annotation simply says that this data is a PNG. So consumers that doesn't understand the annotation can ignore it safely without any problem. The key insight here is the separation of concerns. Tags change what a value means in a specific domain. Annotation add metadata about the value. Both are optional, both are composable, and both are part of the grammar, not a simply string convention. Now let me show you the human-friendly features, because these are very important features for developers who use and adopt this standard. The first thing to say is that xCDN support comment. Comment in line, like this specific example, but also comment inside a block. So this is a block comment. This is very useful for create human readable xCDN files. Another very important things. Keys don't need quotes. As you can see, this is a key, and we don't have the noise, the useless noise of adding quotes to the key. Another important feature, xCDN support trailing commas. If trailing comma is legal, is much more easier to copy and paste things across the code, or reorder items without unfriendly comma gymnastics. Another feature, xCDN support multi-line strings. Multi-line strings with triple quotes. So this is a valid multi-line string. No escape sequences for new line. This feature can be very useful in many cases. Okay. And we also need to mention the streaming support, because a single xCDN stream can contain multiple top-level values, which make it natural for log files or for event stream and for append-only data structure. You don't need to wrap everything in a root array, for example. Now we can talk about the ecosystem, so switch again to the browser. In this repo you can find everything you need. The specification is published with a formal eBNF grammar, and there are also 4 official parser implementation. The Rust parser that maybe can be the reference implementation, and we have also the Python library available also on PyP, so you can write pip install xCDN. We have a JavaScript library, a JavaScript implementation, and a C implementation that can be useful for embedded ecosystems or other system programming. On the integration side, the main type application xCDN is registered with YANA, and I am very proud of this. So HTTP content negotiation works out of the box. File extension is .xcdn, and inside this repository you can find a scheme. So with the scheme prologue mechanism, you can link documents to the schema definition, similar to what JSON schema does for JSON. Everything of this is MIT licensed, is open source, and is freely available on GitHub. That's xCDN. Human first, machine optimized data notation with native types, with semantic tags, with annotation, with streaming capabilities, and with a YANA registered media type. The specs, the grammar, the example, and all the parser repos are linked inside the main repository. So it's easy to access to all these resources. The Python library is on PyP, and the JavaScript library is available on NPM. If you are building a system where data format matter, and it's more or less always matter, give a look to xCDN. And always contribution, issues, and feedback are welcome to evolve this new system. Thanks for watching, and don't forget to keep your thinking cap on.